So I'm going to show you how to go from an equation to write it into my generic notation that we use, as well as how to graph this and then the written description of it. So you're going to have to verbalize the description, you have to write it out. So we have the equation g of x equals x plus 4 quantity squared minus 5. And this, I'm asking you, what are the transformations? So the first thing I'm going to do is, let's see how to write this in our generic notation. So I know that my f of x is going to be x cubed because of the cube right here. So my generic notation would be g of x equals f of, because there's no a in front, the x plus 4, don't need the cube because the cube is the f part, minus 5. All right, so there's my generic notation. Now then I'm going to ask you to write the mapping. Well, our mapping is going to be xy, and that's going to map to something. So remember, everything on the outside affects the y's, everything on the inside affects the x's, but it's opposite because my generic is a minus. So I have x plus 4, so I need to do the opposite of plus, so it's x minus 5. And on the outside, I keep it the same, so that becomes y minus 5, and there's my mapping. So now I want to use my table here to be able to use to do mapping. So what I'm going to do is I want to pick some points that make my life easy: -2, -1, 0, 1, and 2. I define my y value, I plug them back into my f. So -2 cubed is -8, -1 cubed is -1, 0, 1, and 8. All right, so now I have these values. All I do is take my mapping, x minus 5, y minus 5, take my x value, plug it in. This gives me -7, -6, -5. We put a 1 in there, -4, wow, that's interesting. -3 had a moment there. Take my -8, plug it in here. That gives me a -13, a -6, a -5. This becomes -4, and then this becomes 3. All right, so now I have points. I can just simply graph. So here is my parent function. So this is f, and that's going to include these points right here in the middle. So now what I'm going to do is I'm going to plot these points, and I'm going to have my g. So -7, -13 down here somewhere. And then -6, which is close to this, but -6, -6, which is about halfway up. Then -5, -5, -4, -4, and then -3, 3. So my graph kind of doing something like this. Now we're sketching graphs. We're not being precise when we're graphing them, but this would be approximately what my G is. All right, so now what I want you to do after graphing it and everything else is give me a written description of what the transformation is actually doing. I want you to put it in writing. So you can use the same sentence stem. We can say the function, or given the parent function, start with the capital letter, James. Given the parent function f of x equals x cubed, g of x can be created by the following transformations. All right, and then put a colon there, and then just describe them. Let's see, I have a horizontal translation. Let's see, we're going plus, so we're actually going left. A horizontal translation left 5 units, and let's see, we're going down 5, a vertical translation down 5 units. Ooh, I made a boo-boo right here. That should have been a 4. So that last bit of the video was wrong. So just know that that was a 4, and then this should be a 4, not a 5. Trash in, trash out. I didn't write the problem down correctly, therefore I would have gotten everything wrong. But it's good to see that even I write the problems down wrong, even though everything else I did was right. Just by missing one number makes the entire problem wrong. But now that we got it fixed, make sure I end in a period, and I'm good. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.